Good
Morning,
morning, sir.
everyone. Okay, so I'm very sorry. I'm late in the discussion due to very heavy traffic sa SRP. So, unang nadugay. Okay, but we'll start with our topic. But before we start, so we will have first our attendance. Okay, okay. So say present if you are around. Tuto,
Present, sir.
Layon, Umandak.
Present, sir.
Okay. Then Codino, wala. Canonico, wala pod. And then De La Victoria, wala sad.
Present, Tagle, sir.
Okay. Ano? Sumalinog, wala sad. Okay. Kabag,
Present, sir.
okay. Kapisnon,
Present, sir.
Carbos,
Present, sir.
Seniza, Dagle,
Present,
wala.
sir.
Ano? Felices, Gabato, wala sad.
Ganahan
Genon,
sir, gabato sir.
Non-present,
Dugay mo
sir.
tingog. Genon na
Sir, na. Present.
Okay. Hernandez,
Present, sir.
Ibarra,
Present, sir.
Libron,
Present, sir.
Lucero,
Present, sir.
Mahinay,
Present, sir.
Mahusay,
Present, sir.
Negre, wala. Yadas,
Present, sir.
Omega.
Present, sir.
Okay. Umiktin,
Present, sir.
Sumalino, Sumalino. Yapon, Swan,
Present, sir.
Soralta,
Present, sir.
Texon, wala. Balizado,
Present, sir.
Villacampa, wala. Okay. Okay, so before we start with our discussion, guys, so I will be having a recording session first. Okay,
Sir, excuse me, sir. Present de la Victoria, sir.
little
Felices at
Victoria,
sir.
Felices, and little Victoria. Okay, wala na. Okay.
Sir, good morning, sir. Sumalinog present, sir.
So, Alino. Okay. Okay, sa akin, panggi kuha na itong presentation. So allow me to share my screen. Yes. So is it visible now, my presentation?
Yes, sir.
Okay. So last time, guys, so we end up at this topic. So we already discussed about different cost estimation techniques. Okay, so we define already two of them, two um, concepts. Okay, so we have the first one. Okay, the work breakdown structure. Okay. And then also we talk about the cost and revenue structure or the classification. And then also we talk about the last one. Okay. So also we discuss the different integrated approach for the um, second one na to. Okay. So for this morning, okay, so we will continue with the topic. So we will discuss the third one, okay, which is the models. Okay. So the estimating models discussed are applicable for order of magnitude estimates and for many semi-detailed or budget estimates. So they're useful in the initial selection of feasible alternatives for further analysis in the conceptual or preliminary design phase of a project. Sometimes these models can be used in a detailed design phase of the project. Okay, so these models are used, okay, in many types of estimates. So we have three. First, we have the indexes. Okay. Second is the unit technique, and then the third is we have the factor technique. Okay. So first in our list, so we will discuss about indexes. So, saan nagitawag na itong indexes? Okay? So if we say indexes, so these are costs and prices vary with time for a number of results, including uh, technological advances, availability of labor and materials, and inflation. So an index, it is a dimensionless number that indicates how a cost or a price has changed with time with respect to a base year. So it provides a convenient means for developing present and future cost and price estimates for historical data. Okay. So the cost or in that estimate, so the cost of selling price on an item in a year end can be obtained by multiplying the cost or price of the item at the earlier point in time by the ratio of the index value in year k n to the index value of the year k. So we have the formula here, which is C of n equivalent to C of k times k I of n, or the index in that particular year, or index value in that year, over the index value in years, or the IK. Okay? So where our CNF is the estimate cost of price of item in year N. If you say C of K, cost or price of item in the reference year K, then we say K, so this is the reference year in which cost or price is known. And then N, this is the year for which cost or price is to be estimated. So N must be greater than K. Okay? So sometimes in indexes, it is referred as the ratio technique of updating cost and prices. So we can use index technique, okay, that allows the cost or potential selling price of an item to be taken from historical data with a specified base year and updated with an index. So this concept can be applied as well as the top level of the work breakdown structure. Okay. Um, so we will have here an example. So a certain index for the cost of purchasing and installing utility boilers is keyed to 1988, where its baseline value was arbitrarily set at 100. So company XYZ installed a 50,000 pound per hour boiler for 525,000 in 2000, when the index has a value of 468. So this same company must install another boiler of the same size in 2014. So the index in 2014 is 542. So the question, what is the approximate cost of the new boiler? Pila may answer na na, guys. So based on the formula, sir, okay? So we have our formula, um, C of n equivalent to C of k times I of n over I of k. So pila man na to ang C of k ani? So sa di gipangitaan ni nga problem. Hello? What is the problem, or what will be the answer? What is asked in this problem? So the answer is what will be the approximate cost. So therefore, we need to know the C of n in the example problem. Okay? So we already know that our formula for that, okay, is C of n equals C of k times I of n over I of k. Then all of the values are given. So therefore, here, so equals to, so you have our C of k. So asa may C of k na to ani guys? So kini, ano siya C of k? So 525,000, okay? Okay, times, okay, what? So C of n over C of k. So C of n na to is that index over kini. So 524 over 468. So pila may result ana? So result, sir, is 608,000. Okay. Ito lang i-kuhan guys, kaya mura ma-destroy siya. Okay. So the result of that example problem, sir, is we have 608,030. Okay? Okay. Nakuha na siguro kaya may mga kasikas mga tao. Okay. So next. So indexes can be created for a single item or for multiple items. Okay. So for single item, the index value is simplified. The ratio of cost of the item in the current year to the cost of the same item in the reference year times multiplied or it is multiplied by the reference year factor, okay, which is typically 100. So composite index is created by averaging the ratios of selected item cost in a particular year to the cost of the same items in a reference year. So the developers of an index can assign different weights to the items in the index according to their distribution to total cost. Okay? So, for example, okay? So based on the following data, so develop a weighted index for the price of a gallon of gasoline in 2014. So when 1996 is the reference year, having an index value of 99.2. So the weighted place on a regular unleaded gasoline is three times as much premium or either premium or unleaded gas because roughly three times as much regular unleaded is sold compared with premium or unleaded plus. Okay, so these are the prices during that year. So for 1986, premium is 114, 103 for unleaded plus, and then 93 for regular unleaded. In 2010, so 240 for the premium, 230 for unleaded plus, and then 221 for regular unleaded. And then in 2014, 315 for premium, 305 for unleaded plus, and 285 for regular unleaded. Okay? So how can we compute, okay, the weight of this example? Okay? So in order we can compute that, sir, for example, is we will sum up the ratios of the weight of premium, unleaded plus, and regular unleaded. Okay? So therefore, it will be like this. Okay, so for example, okay, in K is 1996 and N is 2014. So the value of I in 2014 is you have 1 times 315 over 114 plus 1 times 305 over 103 plus 3 times 285 over 93 over 1 plus 1 plus 3 times the percentage, which is 99.2%. So therefore, the index, okay, in 2014 is we have 296. Okay? Then if we want, for example, determine if the index in 2016, okay, example, having an estimate to be 327. Okay, so we can use that computation from 2014 to get the corresponding prices of gasoline in 2016. Okay, so by using the computed index in 2014. So to do that, so we have here, for example, our premium. So it's equivalent to 315 cents per gallon. Okay, times 327, which is our index for 2016, over 296, which is the 2014 calculation, okay, which is equivalent to, okay, 348 cents per gallon. Okay, then if we have the unleaded glass, so you have 305 cents per gallon, okay, times 327 over 296, which is equivalent to 337 cents per gallon. And then lastly, we have the regular unleaded, which is 285 cents per gallon times 327 over 296, which is equivalent to 315 cents per gallon. Okay? Question so far?
None so far,
Okay.
sir.
None so
Okay,
far, sir.
nakuha ko na. Okay. So next. So next we have is the unit technique. So sa lang gitawag na itong unit technique in estimating techniques or models. So if you say unit technique, so it involves, okay, using a per unit factor that can be estimated effectively. Okay. So examples of unit technique. So we have the capital cost of plant per kilowatt of capacity, or we can say revenue per mile of a particular delivery truck, or capital cost per installed telephone, okay, or revenue per customer served, also construction cost per square foot. Okay, so those are some examples of unit technique. Okay, so such factors, when multiplied by the appropriate unit, give a total estimate of cost, savings, or revenue. Okay, so here we have an example. So as you can see here, so you have a per unit factor is used, okay, for appropriate number of units. So to find the total estimate of cost, okay, so we will use per unit factor. So for example, we're using per unit factor of say 120 per square foot, okay, and then applying that to a house with, okay, so with 3,000 square feet. So the result of that estimated cost is you have 120 per square foot times 3,000 square feet, which is equivalent to $360,000. Okay? So while this unit technique is very useful for preliminary estimating purposes, such as average values, can be misleading. Okay? So in general, more detailed methods will result in greater estimation accuracy. So it means that we can have an estimate for using the unit technique, but we cannot use this because it may cause misleading to the study or to the analysis of your economic analysis or economic study. Okay? So that's why we need to have more accurate, okay, than not only applying unit factor or unit technique, but use of other techniques as well to have a better accuracy or better efficiency of getting the uh, that not perfect or that not perfect, the greater estimation accuracy. Okay. So next is we have the factor technique. So if say factor technique, it is an extension of the unit method in which we sum the product of several quantities or components and add this to any components estimated directly. Okay, so we have the formula here. So you have C equals the summation of your uh, C C base D or C of D with respect to our D plus the summation of f of m times u of m in respect to m. So where our C here is the cost being estimated, then C of D, we have cost of the selected component D estimated directly, and then f of m, cost per unit of component m, and then U of M, number of units of component M. Okay? Ha? Okay. Excuse. So now we're already done with the three techniques applied or three methodologies used in modeling or having the models or the estimation models, or we call that the estimating techniques. Okay. So now we will continue with what we call the parametric cost estimating. Okay. So what is that all about? Okay. So if we say parametric cost estimating, so it is the use of historical cost data and statistical techniques to predict future costs. So statistical techniques are used to develop cost estimating relationship or CERs that ties the cost or price of an item to one or more independent variables. Okay? So if recall or we recall the chapter 2, okay? So that cost drives and design variables that account to a large portion of total cost behavior. Okay? So as you can see in this um, particular formulation, okay? So as you can see, we have the other technique which is applied in the parametric cost estimating, which is called the power sizing technique. Okay. So in power sizing technique, which is sometimes referred as an experimental model, is frequently used for developing capital investment estimates for industrial plants and equipment. So this particular CR or the cost estimating relationship, okay, recognizes that cost varies as some power of the change in capacity or size. So you have the formula here. So CA equals to CB multiplied with S of A over S of B powered, okay, quantity powered X. So where our C of A is the cost for plant A, so both in dollars of the point in time for which the cost estimate is desired. Then cost B, same. So cost of plant B. Then S of A, size of plant A. Then S of B, size of plant B, which are both in same physical units. And then our X is equivalent to cost minus capacity factor to reflect economies of scale. Okay? So, mo na siyang gitawag na to og power size technique. Okay? So, next is we have what we call the learning curve. So, if say learning curve, so it is a mathematical model that explains the phenomenon of increased worker efficiency and improved organizational performance with repetitive production of a good or service. So the learning curve is sometimes called an experience curve or manufacturing progression function, okay? Which it is an estimating relationship that observed, okay, or that was first observed in aircraft and aerospace industries with respect uh, to labor hours per unit. Excuse. Okay. So, however, it applies in many different situations. So, for example, so the learning curve effect can be used in estimating the professional hours expended by an engineering staff to accomplish successive detailed designs within a family of products, as well as in estimating the labor hours required to assemble automobiles. Okay? So the basic concept of learning curve is that some input resources decreases and per output unit basis as the number of units produced increases. Okay, so most learning curves are based on the assumption that a constant percentage reduction occurs in, say, labor hours as the number of units produced is double. Okay, so here in this learning technique, so most of learning curves assume a constant percentage reduction, okay, occurs as the number of units double is, or the number of unit produced is double. So this is the formula. So you have Z of U equivalent to K multiplied with U power of N. So where our U is the output unit number, C of U is the number of input units needed to produce output unit U. K is the number of input units needed to produce the first output unit. And then S is the learning curve slope parameter as a decimal. Then lastly, N is equivalent to log S over log 2. Or this is the learning curve exponent. Okay? So, for example, assuming, okay, so the first unit of production required 3 hours time for assembly. So the learning rate is 75%. So find the time to assemble the eighth unit, and B, find the time needed to assemble the first 6 units. Okay? So in order to solve that, so we have our first problem. So we solve for the time assembled the 8 units. So you have Z of 8 equivalent to a number of hours, which is 3 times 8, which is the 8th unit, power of the learning rate, which is 0.75, log 0.75 over log of 2. Then we have our uh, time assembled in the eighth unit, which is 1.27 hours. Okay? Then letter B. So we have uh, the time needed to assemble the first six units. So we have here the summation of k, which u equals 1 to x, u power of n. So we have here three times the summation of that value, okay? Uh, log of 0.75 over log of 2, where u equals to 1, 2, 3, 4, 5, and 6. Then it is equivalent to 3 times 3.9346, which is equivalent to 11 point, 11.8 hours. Okay? Nakuha? Like extra ba, guys?
Copy, sir.
Okay. So next. So how can we develop a cost estimating relationship or CR? Okay. So again, if you say CR or the cost estimating relationship, it is a mathematical model that describes the cost of an engineering project as a function of one or more design variables. Okay. So these are useful tools because they allow the estimator to develop in cost estimate quickly and easily. Furthermore, estimates can be made early in the design process before detailed information is available. Okay? So as a result, engineers can use the cost estimating relationship to make early design decisions that are cost effective in addition to meeting technical requirements. Okay? So in order to have our cost estimating relationship, we need to follow these four steps in developing the cost relating or cost estimating relationship. Okay. So first in our list, so we define the problem. Okay. So it means that from the terms of problem definition, so we already talked about that. So this is the first step in any engineering analysis is to define the problem. So a well-defined problem is much easier to solve for the purpose of cost estimating. So developing a work breakdown structure is an excellent way in describing the elements of the problem. Okay, so a review of the completed work breakdown structure can also help identify potential cost drivers for the development of the cost estimating relationship. Okay, so that's the first basic step for developing a cost estimating relationship. Second is we have the data collection and normalization. Okay. So the collection and normalization of data is the most critical step in the development of a cost estimating relationship. So we are familiar with garbage in, garbage out. So from terms of garbage in, it means that without reliable data, the cost estimates obtained by using the cost estimating relationship would be meaningless. So the work breakdown structure is also helpful in the data collection phase. Okay, so the work breakdown structure helps to organize the data and ensure that no elements are overlooked. Okay, so that's the second step, which is data collection and normalization. Third one is we have the cost estimating relationship equation development. Okay. So here in this step, in the development of the cost estimating relationship, is to formulate an equation that accurately captures the relationship between the selected cost drivers and the project cost. Okay? So in terms of cost relating cost estimating relationship. So we have different types of relationship or equation forms. So we have the linear, we have the power, we have the logarithmic, and the exponential. Okay? So those are typical equation forms that is used in defining the equation development. Okay? And then lastly, we have the fourth step, which is the model validation and documentation. Okay. So once the cost estimating relationship equation has been developed, so we need to determine how well the cost estimating relationship can predict cost and document the development and appropriate use of the cost estimating relationship. Okay. So the validation can be accomplished with a statistical goodness of fit measures such as standard error and correlation coefficient. So analysts must be good of fit, okay, or must be fit, okay, and must be understand the measurements, okay, to infer how well the cost estimating relationship predicts cost as a function of the selected cost drivers. So documenting the development of the cost estimating relationship is important for future use of the cost estimating relationship. Okay. So it is important to include in the documentation that the data used to develop the cost estimating relationship and the procedures used for normalizing the data. Okay. So, question so far. La.
Wala ra, sir.
Okay. So, any questions so far?
None so far, sir.
Okay. So, since no questions, okay. So, thank you for listening for the discussion, and hopefully you understand. So, this is the end of chapter 3. By the way, and next week, since we have our intramurals, so we cannot met or we will not meet. Okay. For group one, so we will have or I will give you the report. Okay, in our canvas, so I will be one having the list or the topic that you will do for the next reporting, which will be on November 7th. Okay. So start sa new report or start as a first group at or on November 7th. Okay?
Okay, sir, noted.
Okay. So again, thank you so much guys for listening and thank you. So before we go, so first again, I will call some people who is not around during the attendance. Again, Negre,
Present, sir.
okay. Then Texon, wala. Guess Texon, absent. Villacampa, wala sad, absent. Si Codino, Nas Codino, absent sad.
Pamilya Kamba, sir.
Ha?
Naabilyakan pa, sir.
Taas pilya kampa. Di lagi mo maning dayon. Okay? Then si Koan, Cody na wala absent. Okay? Then si Canonigo, absent po. Okay? And then, wala naman siguro. Okay. So, thank you so much guys again for listening our discussion. And then, class dismiss, okay? Goodbye, guys.
Thank you, sir.
Thank you, sir.
Yes,
Bye,
sir.
sir.
Bye, sir. Thank you, sir.
Goodbye, sir. Thank you, sir.
Yes, sir. Thank you, sir.